Okay, now we're going to do wave interaction notes. So go ahead and find that part of your notes, and we're going to start there. And we're going to first start with the 4 basic types of wave interactions. We have reflection, refraction, diffraction, and interference. Now, these can be seen in mechanical and non-mechanical. We're going to talk about that as we go through. Let's talk about reflection first. Reflection occurs when a wave strikes a barrier and it bounces back. We've already talked about how longitudinal waves do that, right? Sound waves or echoes. So longitudinal mechanical waves, with a sound wave, you talk, it hits a barrier, comes back, and we call that an echo. So other examples, the reflection of light waves creating a mirror image of a landscape when they hit the surface of a lake. You know when you're standing around a lake or a body of water and you can actually see the reflection of the trees that are around the lake or the reflection of some other type of landscape that's surrounding the lake, and you can actually see it in the water. It looks like a picture. That's reflection of light. So that's an example of a reflection of an electromagnetic wave. An example of a surface wave would be water waves hitting the side of a boat. When water waves hit the side of the boat, they hit it and then they hit the boat and then they back off, right? They go back. And that actually interferes. It actually causes the waves to become smaller. Whenever you hear an echo, it's not the same amplitude of sound that you heard from the initial voice. When it comes back to you, it's been interfered with, so it is a little bit less, right? Now let's talk about refraction. Refraction occurs when waves bend because the speed of the wave changes. And it's because the waves have changed mediums, okay? So the bending, the reason why the wave bends is because it went from one medium to another. What you can do at home today, you can actually fill, if you have a glass that you can see through, fill the glass 3/4 of the way with water, put a spoon in it, and you're going to see how light waves can refract and bend. Because when you're looking at that glass with a spoon in it, it looks like the spoon is bent. Now the spoon we know is not bent, but what happened is the light wave's bent, so it's showing our eyes, it makes our eyes think the spoon is bent. And the reason that happens is because the light waves are flowing at a certain speed in air, which is where the top part of the spoon is. And when they change, when the spoon changes medium, the light waves, once it goes into a liquid, it has sped up, right? Because gases are when the light waves are the slowest, liquids, and then solids. So since there was a change in speed for those light waves, it's actually creating a bent image that our eyes see. Now diffraction. Diffraction is the bending of a wave around the edge of an object. And the amount of bending that the wave would do depends on the wavelength of the wave and the size of the obstacle. We're actually going to look at this right now. All right, this would be a water wave or a surface wave. It's dripping from a faucet, and I put a barrier in here. These are the yellow bars. So the water's trying to go through. Let me show you the wave. This is a graph of the wave when it's being dripped. It's got a very high amplitude and a very high frequency, but as you see, once it hits the barrier right here, it's diffracted. And so it actually, the amplitude lowers and the frequency even kind of lowers because it's interfered with the wave. This is one of those types of interference, and this is diffraction. So this would be water. An example of a sound wave diffracting is going to be the same thing. If there's a barrier, it's still going to slow that sound wave down and also decrease the amplitude. See how the sound wave has got a very large amplitude to begin with, but once it hits the barrier, it starts to slow down. And so this is the exact same way as water. Now let's look at light. It actually is similar as well. And I want us to start this over again. Oh. Let's see if I can, I don't know if I can restart it. Oh, reset all. I want you to see it from the beginning. See how the light is coming out from the source? And if we put a split in there, all of a sudden, it's got an interaction, and it's going to change the wave. So let's look at the graph again. See how the amplitude is so large and the frequency is so large at the beginning? But then as it hits the diffracted area, once it's diffracted, it slows down and the amplitude is down a little bit. Now let's talk about interference. Interference is when one or more waves arrive at the same place at the same time. We have already talked about this in regards to standing waves, okay? So this is constructive interference and destructive interference. Constructive is when the waves combine to make a larger wave. Destructive is when the waves combine to make a smaller wave. And we talked about that with nodes and antinodes. So this completes our notes on wave interactions. And you just need to make sure that you know an example of each type of wave interaction for mechanical and electromagnetic so that you know and have those examples in your mind, because it will help you understand wave interactions much better. So this is what I'd like you to do for your summary. I would like you to write down, or actually let me draw you a chart. Okay, for your summary, write this chart on a piece of paper on the back of your notes, and I want you to fill it in with an example of each type. So for reflection, I want an example of a mechanical wave. I want an example of a non-mechanical wave. For refraction, I want an example for a mechanical wave and one for a non-mechanical. For diffraction, I want an example for both. Okay? And I hope you have a great evening, and I'll see you in class.